easy, medium, and difficult. So let's do what we call a sequence of partial sums. And we did one earlier, but it was just for fun. We really like to do these on what we call a telescoping series. And so let me show you what that is. It looks like, I'm going to make up one that looks like this. 1 over, I'm making up one, but I'm looking at the book. 1 over, hang on a second. Okay. 1 over n minus 1 over n plus 3. And I want to start this at n equals 1 to infinity. So this is my series. And I'll tell you what, let's just run through our rules real quick. Let's try a divergence test real quick. How do you try a divergence test? You quickly take the limit as n goes to infinity. When you take the limit as n goes to infinity, what do you get? I think you get 0 minus 0. I think you get 0. What does that tell you?
It's not.
Okay, thank you. It tells you nothing. Right. You with me? Right.
Yeah.
Right. You do a divergence test. You find out the limit is 0. You know nothing. It's got a chance to converge, but who knows? Okay. So anyway, that failed basically. Is it a geometric series? Anybody want to? Does it look like it doesn't? No, it doesn't look like that pattern. You know the pattern, I hope, or you'll get to know the pattern. No, it's not geometric. No. So I'm going to try this thing. I'm going to try to build myself a sequence of partial sums. If you remember, it was a pain. To build a sequence of partial sums, you need the sum of the first term. Well, that would be me plugging a 1 in there. So that would be 1 minus 1/4. And I don't want to clean it up if you don't mind, but that's plugging a 1 in there, and that's the sum of the first term. By the way, the sum of the first term is not what you want. Let's do the sum of the first 2 terms. That would be S2. The sum of the first 2 terms of the sum of the first 2 terms of the series is the second term of my sequence of partial sums. Okay, plug in a 1, and what do you get? 1 minus 1/4 plus, let's plug in a 2. That would be 1/2 minus 1/5. You guys with me? I don't want to add this stuff up. The truth is, I don't want S3 and S4 and S5. If you know what I really want? I want Sn. I want Sn. Because you remember, if I'm building a sequence, how do you tell if a sequence converges? Take the limit as n goes, take the limit of Sn as n goes to infinity. So I want Sn. So here we go, here we go, here we go. So Sn is the sum of the first n terms. Okay, well that's the first term, which is that. Okay, the second term, which is that one. This is so cool. You better turn your paper sideways. Watch this. You need the third term. The third term would be 1/3 minus 1/6. I need the fourth term. The fourth term would be 1/4 minus 1/7. You guys with me? Mm-hmm. I need the fifth term. The fifth term would be 1/5 minus 1/8. I need the sixth term. That would be 1/6 minus 1/9. Plus, let's just skip on down, dot, 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 dot. You know what I need now is the nth term. The nth term is what you get when you plug in an n, which is 1 over n minus 1 over n plus 3. Okay, I'm done. That's my Sn. Now what do I want to do with this Sn? I want to take the limit of Sn as n goes to infinity. Now hold on a second though. The reason we like to do sequence of partial sums problem on a telescoping series is because watch what this guy does. It collapses in on itself. Maybe you can see it. Some stuff cancels here. It totally collapses in on itself. Maybe that's why we call it a telescoping series. You know how a telescope, you collapse it, put it in your pocket. Aye, lady. You know what I mean? It's like a telescope collapses in on itself. This collapses in on itself. Can you see the game here? What happens here? This negative 1/4 is going to cancel with this 1/4.
Negative 1/5.
Now check out something. Is that 1 going to cancel? I don't think that 1 is going to cancel with anybody. And I don't think that half is going to cancel with anybody. I can look down the road there. But look at this negative 1/5. That cancels. I don't think this 1/3 cancels with anybody. But look at the negative 1/6. It cancels. What about the negative 1/7? I think it's coming next. If I see the pattern, the negative 1/7 is coming next. And the negative 1/8 is going to come later off of that. And then the negative 1/9 is, I think the rest of it cancels. What you're really looking for is who doesn't cancel. And that was these first few dudes here. So guess what? We just figured out that this Sn has collapsed into 1 plus 1/2 plus 1/3. Now wait a minute. When you get down here, don't get too freaky about this, but somebody canceled with somebody earlier. Do you agree? Maybe? The truth is, I don't want to get too I don't want to try to track it down because, let me just pretend that guy cancels. And then what I have is a negative 1 over n plus 3. The reason I don't want to get too worried about those details is because what am I about to do next? Now that I have Sn, what am I about to do next? Take the limit as n goes to infinity. And regardless of what's left down there, what happens to it? It goes to 0. So that crap goes to 0, and what's left? What's the answer? 1 plus 1/2 plus 1/3. That's the answer. We just took the limit of the Sn as n goes to infinity. And we left with, this is the answer. 1 plus 1/2 plus 1/3. We've got to get a common denominator. 1 plus 1/2 plus 1/3. Common denominator of 6. 11/6. I think it's 11/6. Cool, dude. What did we do? We took this series, we built a sequence of partial sums. What was cool about this sequence of partial sums is that it collapsed on itself. That's what was cool about it. And it was easy for me to figure out the nth term. And it was easy for me to take the limit of the nth term and find out it converges to 11/6. The sequence of partial sums converges to 11/6. So guess what the series does? It converges to 11/6.
How often are we going to be having to worry about that?
Well, there's a few in the homework, and there's one on the test, or 2, or 1. They're a pain, kind of, right? You could solve, but you followed it. I mean, it's just a little bit tedious to write that all out, but really you don't need this. Really, you just need to start trying to write this and wait and watch it telescope and collapse and boom, bam, and then you're done. There is a little, let me just say this. In the homework, they got some that look like this. If it looks like that, I mean, to get it to telescope, I want this fraction minus this fraction, so I can build these fractions minus fractions, you know, and watch it telescope. So when they present it to me like this, it's not in the form I want, and I need to do a little work first, and the book even gives me a hint. Guess what I got to do first? Break it up. I need to go do partial fraction decomposition. I mean, you can't just break it up casually. You have to break it up properly. You have to go off. Remember how you did your, you got to split it up into a couple of fractions. You know what I mean? You got to go do a little partial fraction decomposition, then come back, and you'll have a telescoping series. That's not that hard, though. Remember, we learned that. So we got to do that on some of these. So some of these are given to you like that, and the book even hints that you got to do a little partial fraction decomposition before you can let's just finish it. Let's just finish it. You ready? This takes 3 seconds. Watch. On your mark, get set, go. Do you remember what to do? Multiply by the common denominator. You get 1 on this side. You get a times n plus 1. You get b times n. Remember that game? Okay, now what do you do? Well, right, what do you do? Like, let n equal 0? Let n equal 0. That's cool. That'll zero out that term, and that'll put a 0 right there, and you'll have basically a equals 1. This is an easy one here. Okay, cool. We just found out a equals 1. We should also let n equal negative 1. That'll zero out that term. This will be a 1. This will be a negative b when we let n be negative 1. And so b is negative 1. So, you know, you don't always get 1s. Sometimes you get halves and thirds and sixths. I mean, anyway, but these came out to be 1s. And so what we have is, instead of this series, we just decompose this fraction. And it is now 1 over n minus 1 over n plus 1, right? It looks kind of a lot like mine, but a little different. And now you could go do the, yeah. So it's just a little pre-step there to get it looking like a telescoping series, to get that separated. Cool, I'm gonna quit today. Thank you for listening and working and everything.